Okay, so today's lesson, we are going to go over completing the square, and then we will use completing the square to solve some quadratic equations, and we will also use it to convert from standard form into vertex form. So there's several methods to solving quadratic equations, factoring and using the zero product property, finding square roots if the quadratic is of the form x squared equals d, completing the square, using the quadratic formula, and the graphing calculator or graphing. So completing the square basically means that we're going to write the trinomial as the square of a binomial, which then will allow us to square root and solve for x. So the steps for doing this method are the following. The first thing you'd want to do is get the constant term alone on the right side of the equation so that you can then create your own c value that will make it a perfect square trinomial. When you do that, you do it by finding half of the b, squaring it, and adding it to both sides. At that point, you can then factor the left side using the square of the binomial or perfect square trinomial factorization, and then you can solve by using the square root method. So writing an expression as the square of a binomial. So the square of a binomial is when you have something where you have x plus or minus some number squared, which essentially means you had two factors that were exactly the same that you could then write once with a square on it. So this typically happens when you have a perfect square trinomial. And if you remember from our factoring lesson, a perfect square trinomial is when you have a perfect square for your first and your third term. And the middle term, if you divide it by 2 and square it, you would get your third term. So half of 6 is 3, and 3 squared is 9. So that's the relationship there. Or if you look at number 2, half of negative 10 is negative 5, and negative 5 squared is 25. Now you'll notice, because you're going to square whatever you get for half that middle term, when you square something, you're multiplying it by itself, it'll always be positive. So these problems will 100% of the time have to have a plus c value in order for this to work. Okay, so for example, when you are factoring, just doing the regular traditional factoring, you would say what two numbers multiply to get 9 and add up to get 6, and it would be positive 3 and positive 3. You see how you get the same thing twice. That's because this is a perfect square trinomial. So because of that, you know it's just going to be x plus 3 squared. So same thing for number 2. I don't really have to go through the trouble of factoring into those two parentheses because I know it's just going to be half of this negative 10, which is negative 5, x minus 5 squared. If you did do it the traditional way, the two numbers that multiply to 25 that add up to negative 10 would be negative 5 and negative 5. Okay, so what we want to do when we complete the square is we want to figure out, well, what c value will make this a perfect square trinomial, because then we know we can factor it into that square of a binomial. So to find that c value, we're going to take that center number there, which is positive 10, and divide it by 2, which gives us 5. And then you're going to square that. You'll always get a positive, in this case, positive 25. So that means this would be x squared plus 10x plus 25, which is now a perfect square trinomial. So in order to factor that, I can just simply do x, and then whatever this term is here, divide it by 2, and that's what will go in my parentheses with the square on the outside. So for number 2, to find my c value, negative 14 divided by 2 is negative 7. We square that, we get 49. So my perfect square trinomial is x squared minus 14x plus 49. And to factor that into a square of a binomial, I'm just going to do x minus 7 squared. Okay, number 3. Now this time you might notice that when you go to divide your 7, it's going to be a decimal. So rather than do a decimal, we're going to leave it as a fraction. When you square a fraction, both the numerator and the denominator get squared. So my trinomial now is x squared plus 7x plus that fraction, 49 over 4. So if I were to write this as the square of a binomial, it would just simply be x plus and then 7 over 2, and you can leave it in that fraction form. Okay, number 4. This time I have negative 3 divided by 2, and I'm going to square that, which is going to give me a positive 9 over 4. So my perfect square trinomial will be x squared minus 3x plus 9 over 4. Then I'm going to write this as the square of a binomial. So it's just going to be x minus, and then that center term, 3 over 2. All right, the next one, 12 divided by 2, which is 6. 6 squared is 36. So my perfect square trinomial is x squared plus 12x plus 36. Therefore, my square of a binomial is just going to be x plus 6 squared. For number 6, we have negative 5 divided by 2. We're going to square that, which will give me 25 over 4. So x squared minus 5x plus 25 over 4 is my perfect square trinomial. And then my square of a binomial will be x minus, since it's an odd number, it's just going to be that fraction over 2. Okay, so now that we know how to write the square of a binomial and make things a perfect square trinomial, we want to use that to solve these quadratic equations by completing the square. So if you remember when I kind of reviewed the notes in the beginning, I said the first thing we're going to do is move that c value over. And the reason is because right now this is not a perfect square trinomial. And the way you can check it is 6 divided by 2 is 3, 3 squared is 9, and that's not a negative 8. So we're going to move that 8 over to the other side. So we have x squared plus 6x. And now we've moved our 8 to the other side, making it positive. Now at this point, you want to figure out, well, what is that c value that makes this a perfect square trinomial, which we already said was going to be 9. And you just get that by taking your middle term, that b value, dividing it by 2, and then squaring it. Now at this point, because you made this a perfect square trinomial, you can now factor it into the square of a binomial. So it's just going to be x plus 3 squared, because 6 divided by 2 is 3. On the other side, whatever's over there, you're going to combine like terms. In this case, it would be 17. So now you can solve this by using the square root method that we did in the last couple sections. So when we square root something that's squared, they basically cancel each other out. So we're just left with the x plus 3. And then over here, since 17 is not a perfect square, we're just going to leave it. But remember, all radicals have both a positive and a negative. So now we're going to move that 3 over to get the x by itself. X equals negative 3 plus or minus radical 17. And that would be our 2 solutions for that problem. Now remember, it's 2 solutions because of that plus minus. So negative 3 plus radical 17 would be one of your solutions or x-intercepts. Negative 3 minus radical 17 would be your other one. Okay, so let's take a look at number 2. So 36, I'm going to move that over. So I have x squared minus 8x. And on the other side, I now have negative 36. Now, whatever that c value is, we have to add to both sides of the equation in algebra. Whatever you do to one side, you do to the other. So half of 8, or half of negative 8 is negative 4, but it doesn't matter because I'm going to square it, and then I'm going to get positive 16 anyway. Now, in my square of a binomial, when I factor this perfect square trinomial, I'm going to have x minus half of 8, which is 4. And then over here, I'm going to combine those like terms to get negative 20. Okay, now this is one of those situations where when I go to square root it, I have negative 20. Now you might remember how to factor the 20 or break it down using your little factor tree method. And you do get positive or negative 2 radical 5. But because this is a negative 20, and we're taking the square root of a negative, remember that that I value has to come out as well. And then finally, we would bring that 4 over. So x equals 4 plus or minus 2i radical 5. Okay, so then the next two questions, following the same pattern here. So at this point, you can see we're starting out by taking that C value and moving it over. When you move it over to the other side, it's going to be the opposite sign. Now we have to take that B value, divide it by 2, and square it to get the C value that will make this a perfect square trinomial. So 12 divided by 2 is 6. 6 squared is 36. So now when I factor this perfect square trinomial into the square of a binomial, it's x minus 6 squared. And I combine my like terms over here on the right, and I get 8. Square rooting both sides, and I'm left with x minus 6 equals positive or negative. And when you simplify radical 8, you're going to get to radical 2. And finally, we're going to add the 6 to the other side. 6 plus or minus 2 radical 2. Okay, number 4, starting out, moving that C value over to the other side. So I have a negative 10 when I move it over. The C value that will make this a perfect square trinomial, well, 3 divided by 2, and then we're going to square it. So that's actually going to be a fraction in this case, which is going to be 9 over 4. Or if you want to write it as a decimal, you can do that too. So now I have x minus 3 over 2 squared equals, and negative 10 plus 9/4 is going to be 7.75 or 7 3/4. So if it helps you to write it as a decimal, you can. If you write it as a fraction, that's fine too. Okay, so now we want to solve this. Now this is where I might want this as a fraction, because if you have a decimal and it's been simplified or abbreviated at all, it's not going to work out when you go to square root it. So that's why we kind of want to keep it in fraction form whenever we can. So if you have a calculator, you can simply add this up on a calculator. But since I don't want to pull that open right now, if I were going to add these by hand, let's say, so I have to make a common denominator. So negative 40 plus 9 would be negative 31 over 4, and that's what I'm going to have over here. Now that's important because now I'm going to square root both sides to solve this. And I have x minus 3 over 2, and then over here I have positive or negative. On the top, right, I have negative 31. Well, 31's a prime, so that's not going to come out, but there was a negative, which will come out as that I. And the bottom is square root of 4, which simplifies to 2 since it's a perfect square. So now, to finish that up, I would add my 3 over 2 to each side. So x would equal 3 over 2 plus minus I radical 31 over 2. Now that's one way you can write the answer. Notice that each of those terms is written separately with its own denominator, but since they both have the same denominator of 2, you could also see it written like this. 3 plus minus I radical 31 over 2. Either of those would be correct. It just depends on what format it would be written in. Okay, so now if you get to the next couple problems, you'll notice that now we have this coefficient in front of the x squared. So whenever that happens, the first thing that you need to do is divide it out from everything. Whether it's a GCF or not, whether it divides evenly or not, you still need to divide it by everything. So first thing we're going to do here is obviously divide everything by 3, both sides of the equation. So we have x squared minus 2x plus 4, and of course it's still going to equal 0. Now we would solve the problem just like we did all the other ones on the last previous page. So x squared minus 2x equals, and then 4 becomes negative when you bring it over. So now we got to figure out, well, what is that c value? So half of negative 2 squared is just going to be 1. So now We're going to factor this into the square of the binomial, x minus 1, because half of 2 is 1. On this side, we combine the like terms. We get negative 3. Now we can use our square roots to solve this for x. X minus 1 equals positive or negative I radical 3. Add the 1 to the other side. X equals 1 plus or minus I radical 3. Okay, now number 6, again, first thing we need to do is divide everything by that coefficient of the x squared. In this case, it's a 2. So that's going to leave us with x squared plus 6x, and on the other side, the equal sign, we have a 9. Now, at this point, normally we would move over that c value to the other side, but it's already moved over, so we don't have to worry about it. Now, a couple people might be like, wait a minute, why can't I just move the 9 back to the other side? Because half of 6 is 3, and 3 squared is 9. Well, you could, except if I move this 9 over, it becomes a negative, and it always has to be a positive c value for it to be a perfect square trinomial. So even though the number is correct, the sign is not, so we can't do that. So this will have to be a positive 9 on each side. So now I can factor this into my square of the binomial, x plus 3 squared. 9 plus 9 is 18. And now I can solve using my square roots. X plus 3 equals positive or negative. And if you do your factor tree for 18, you get 3 radical 2. And then we're going to subtract our 3. X equals negative 3 plus minus 3 radical 2. Okay, number 7. So again, just practicing this, okay? So we're moving that 9 over to the other side. When we move the 9 over, it becomes a negative. Now we got to make this into a perfect square trinomial. So half of 8 is 4, 4 squared is 16. Now we can factor that perfect square trinomial into the square of a binomial. So it's just x plus half of that middle number, which is 4. Negative 9 plus 16 gives me 7. Solving with the square roots. X plus 4 equals positive or negative radical 7. And then moving over that 4, so we get x equals negative 4 plus or minus radical 7. Okay, number 8. Moving the 104 to the other side, which makes it negative 104. Figuring out our c value to make it a perfect square trinomial. Half of 20 is 10, 10 squared is 100. Adding that to each side. Now we can factor our perfect square trinomial into the square of a binomial by dividing that middle number there. So x minus 10 squared equals negative 4. Using our square roots to solve. X minus 10 equals, and this is going to be positive or negative 2i. So 4 is a perfect square, so it comes out as plus minus 2, but because of the negative on the 4, you also need that imaginary number 2. And then we're adding 10 of each side. X equals 10 plus or minus 2i. Excuse me. Okay. All right, so now we have 2 more, and these 2 also have those coefficients in the front. So we just have that added step where we have to divide that coefficient out from everything. So this first one, we're going to divide everything by 6, leaving us with x squared. 14x plus 50 equals 0. Moving the 50 over to the other side. So negative 50. And now we have to figure out, well, what is that number that goes in there? So half of 14 is 7, and 7 squared is 49. So now I can factor this. X plus 7 squared. And over here, I combine those like terms, I get -1. Now I can use my square roots to solve. X plus 7 equals plus or minus, and it would be 1i. So I'm just going to write the I. And then finally, I subtract the 7 so that I can get that x all by itself. And I have x equals -7 plus or minus I. All right, and then the last problem in this half of our lesson, we're going to divide everything here by -3, leaving us with x squared minus 8x plus 9. We are going to move that 9 over to the other side so that we can find a c value that works for us. Half of 8 is 4, and 4 squared is 16. Now I can factor my perfect square trinomial into a square of a binomial, x minus 4 squared. And over here I have a 7. Lastly, using square roots to solve, x minus 4 equals positive or negative radical 7. And then finally adding the 4 over, x equals 4 plus or minus radical 7.